Hello all, welcome to Vista's Learning. This is Rakshitha, your chemistry tutor. So, as we all know, we are dealing with an important sessions from last 4 classes, right? We are dealing with a topic, something called as one-shot revision. So, still now we have finished the first 2 chapters. Which are those? The first one is chemical reactions and equation, and the second one with acid, bases and salts. So today we are going to our third chapter, the same third important, one of the important chapter in your chemistry. Which is that? Yes, it is metals and non-metals. So in today's class, what are we going to learn? As always, we are going to learn the important concepts. Like important concepts, you're supposed to remember in the examination point of view. Followed by, in our next sessions, we will be dealing with the continuation of the topic. With that, the probable questions for the exams. So let us start today's class. As always we do, first we'll note down what and all we learn in our topics, in metals and non-metals topic. So we are first going to learn about physical properties, chemical properties, metals reacting with water, metal reacting with solutions of other metal salts, and reactivity series, properties of ionic compounds, occurrence of metals, and lastly corrosion. So in today's session we are going to learn properties of ionic compounds. See the occurrence of metal and corrosion. With that, the probable questions for the exams you are going to study in our next session. So let us move. First main thing, what are you supposed to remember in metals and non-metals is their physical properties. So it is a very important question, students, the physical properties of metals and non-metals. And also it can be asked as give the differences between metals and non-metals. Give the physical properties differences between metals and non-metals is one of the very important questions in the examination point of view. So when you look into the points, you can see I will go on explaining one by one. So when you know metals are usually hard in nature. So when it comes to metals, they are very hard in nature. So when it comes to non-metals, they are soft, the opposite of metallic character. Then they always exist in the solid form. So their existence will be in solid form. When you move on to non-metals, their existence in either is in solid or in gaseous form. Okay, so the metals will be existing in solid form and the non-metals will be existing in solid as well as gaseous form. Then they are malleable. What do you think this malleable is? What comes to your mind when you remember the word called as malleable? Yes, malleable is nothing but sheets. Okay, the thing is the metals whatever we are taking, they can be converted or they can be made into the form of sheets. That is possible in our metals. But when it comes to non-metals, it is not possible. So they are non-malleable. So malleable is nothing but the metals which we are taking, they can be converted or made in the form of sheets. But when it comes to non-metals, it is not possible to make them into the form of sheets. Followed by they are ductile. The next important characteristics of metals is they are in ductile form. What is this ductile? Yes, it is nothing but formation in the form of wires. So the ductiles, the metals which we are taking, they can be made in the form of wires. But when it comes to non-metals, they are non-ductile. So these are the very 2 important characteristics you have to remember, students, of metals and non-metals. Which is it? They are malleable. Metals are malleable and non-metals are not malleable. And metals are ductiles and these are non-ductiles. Moving on, these are good conductors of electricity. So it is metals allow the electricity to pass. So that is called as something called as good conductors of electricity. So when it comes to non-metals, they are bad conductors of electricity. Okay. Then they are lustrous and sonorous. What do you mean by lustrous? Yes, lustrous is something but they are shiny. You can see when you see our gold, when you see our platinum, silver, copper, these all are metals. So they all are shiny. So what is the meaning of lustrous? It means shiny. Okay. So sonorous is nothing but it allows the sound to pass. That is called as sonorous. So these characteristics, the metals have these next important characteristics are they are lustrous, that is they are shiny, and sonorous, they allow sound to be passed. When it comes to our non-metals, they are non-lustrous and non-sonorous. They are not shiny and the passage of sound is difficult. The last point is the metals have high melting point and our non-metals have low melting point. So these are the important points which you have to remember when it comes to physical properties of metals and non-metals. I am repeating it once more. Metals are hard, these non-metals are soft, and it exists in solid, this exists in solid or in gaseous state, and these are malleable, these are non-malleable. Malleable means they can be made in the form of sheets, and these are ductile, that means they can be made in the form of wires. These are non-ductiles. These are good conductors of electricity, these are bad conductors of electricity. Followed by these are lustrous and sonorous, these are non-lustrous and non-sonorous. They have high melting point and they have low melting point. So this is very important question in your examination point of view. Okay. Moving on, there are few exceptions when you see with the properties of metals and non-metals. What are those exceptions? You can see lead and mercury are poor conductors of electricity. What did we learn? Metals are good conductors of electricity, right? In that, our lead and mercury are poor conductors of electricity. Followed by, let's deal first with metals and then let us move on to non-metals. Mercury exists in liquid form. You can see, right, the mercury, whatever is there, it exists in liquid form. We learned that metals will be in the solid form, right? There are few exceptions where mercury will be existing in liquid form even though it is a metal. Then gallium and cesium have low melting point. So gallium and cesium are metals are having low melting point. What did we learn? Our metals have high melting point. So the exception is here, gallium and cesium have low melting point. Then alkali metals are soft. The alkali metals, which are those alkali metals, are sodium, potassium and lithium. These are soft in nature, but usually what is the thing? Our metals are hard in nature. So these are the exceptions also. It is very important to remember, students. Okay, let's move on to non-metals. Iodine is lustrous. So when you have seen, you might have seen the iodine, right? That is, when you look into an iodine, you can see those are shiny in nature, right? So what our non-metals are usually, they are not shiny, right? There is one exception, that our iodine is lustrous. Followed by graphite, whatever is used, that is a good conductor of electricity. So whatever graphite is basically a non-metal, but it is a good conductor of electricity. Usually non-metals are bad conductors of electricity, right? But graphite is good conductor of electricity. And the last one is diamond is hard with high melting point. So usually they are not hard substances which are non-metals, but here an exception is diamond is hard and they also have high melting point. Usually non-metals have low melting point, right? But diamond is hard and they have high melting point. So these are the exceptions in the physical properties of our metals and non-metals. Moving on, next important topic, that is our chemical properties of metals. So what are the chemical properties of metals? We will learn one by one. The first one, reaction of metals with air. So as I had always told, every time you have to remember the general equation, students. When you remember the general equation, it is very easy for you to write the reaction, what exact reaction happens. So what does it happen here? You can see our metal is reacting with air, that is our oxygen. What is the product you are getting here? Metal oxides. So the formation is metal oxides, which is basic in nature. So for that I have taken one of the example. We are taking copper and treating with oxygen. You are getting CuO, right? CuO is our metal oxide. Okay. So when you are taking our metal and treating it with air, you are getting a metal oxide. So for that, one of the example is we are taking copper and treating it with oxygen, we are getting CuO. Followed by aluminium, which is our metal, we are treating it with oxygen. What is the product? Al2O3. So Al2O3, our aluminium oxide, is one kind of a nature. It is amphoteric. So what is amphoteric? What do you think comes to your mind when you hear the word called amphoteric? Keep thinking, okay? Because actually you're going to learn in today's class, or it is a revision for you to know what is amphoteric, which is again one of the important kind of question which can be asked in your exam. So here our aluminium oxide, whatever it's forming, that is in the form of amphoteric in nature. Okay? Yes, moving on. Yes, here comes what is amphoteric oxides. You can see a metal oxides which reacts with acids as well as base. This is called as amphoteric oxide. So whatever we are taking our metal oxides, that will be reacting with both our acids as well as base to form salt and water. So this is called as our amphoteric oxide. So amphoteric oxide or amphoteric in nature means the first thing which you have to come to your mind is whatever the metal oxides which you are taking, that will be reacting with both our acids and bases to give what? To give salt and water. So for that example, we are taking Al2O3 and we are treating it with HCl, okay, which is an acid. So you will be getting our aluminium chloride with the formation of water. Our aluminium chloride will be a salt and H2O, which is nothing but water. So this is one of the example for acid. So our HCl here is in acid form. Followed by, we are taking the same Al2O3 and we are treating it with base. Okay? We are treating it with base. So when our metal oxide is reacted with base, we are getting NaAlO2 with the formation of water. Again, this is the salt. So there can be a question like, what is an amphoteric oxide? Give an example. You can give one example with acid and you can give one example with base. There are a lot of other examples also given in your textbook. You can refer with that, right? So this is also one of the important concept which you are supposed to remember in the examination point of view. Moving on, yes, sodium and potassium will be reacting vigorously in water. Okay, this is again one of the key points which you are supposed to remember when it comes to reaction of metal with air. So our sodium and potassium will be reacting vigorously. The reaction is very vigorous in air. You know why the sodium is kept in immersed in kerosene? Do you know why it is kept in immersed in kerosene? Yes, it is because sodium is very reactive when it is exposed to air. So that is the reason it is immersed in kerosene, so that it will not be exposed much to air. If at all it is exposed to air, it might be highly explosive and it might catch fire. That is the reason sodium is always kept inside the kerosene. So sodium and potassium will be reacting vigorously in air. This is also one of the question which can be application type of a question which can be asked in your examination, which is that why sodium is kept or immersed in kerosene. Okay. Next, our aluminium, magnesium and zinc does not react with air. Aluminium, magnesium and zinc are not reacting with air because of protective layer. These three things has a protective layer on that. There is a layer which is formed that will not allow the reaction to happen with air, right? Then coming to silver, gold and platinum, they do not react at all. They will not react with air. When you see in our reactivity series, I hope you remember what is reactivity series. Never mind, if you don't remember, we will learn about it in today's class also. So when you see in a reactivity series, you can see where is our gold and the silver placed, right? It is a very, very low reactive. Its place has a very low reactive. So it will not be reacting with air at all. Okay. Then Fe does not react. Usually our iron does not react, but iron fillings will be reacting. The small iron fillings, whatever we use, that will be reacting with air. But Fe as such will not be reacting with air. Moving on, reaction of metal with water. Now, air we are done. Now we will go to water. So what is the general equation here? Metal plus water. We are getting metal oxide with the liberation of our hydrogen gas. Okay. So the liberation of hydrogen gas is happening here with the formation of metal oxide. Later, this metal oxide is again treated with water to give what? Yes, our metal hydroxide. So these are the two reactions, general equation which you are supposed to remember when it comes to reaction of metals with water. What is it? Metal plus water, you will be getting metal oxide with the liberation of H2 gas, followed by metal oxide and water, you will be getting metal hydroxide with again the same liberation of H2 gas. Now, sodium and potassium reacts vigorously with water. Okay, our sodium and potassium, whatever we are using, it will be reacting very vigorously with water, and also it is exothermic in nature. Now, the reaction you can see, we are taking sodium and treating with H2O, we are getting sodium hydroxide with the liberation of H2 gas. Next, Mg does not react, our magnesium does not react with cold water, but it reacts with hot water. Okay, our magnesium metal is not going to react with cold water, but it will be reacting with hot water. And aluminium, zinc and iron does not react either with hot nor with cold water. So these are the important points which you are supposed to remember when it comes to reaction of metal with water. What is it? Sodium and potassium reacts very vigorously with water. Our magnesium does not react with cold water, but it reacts with hot water. When it comes to aluminium, zinc and iron, it does not react at all with cold nor with hot water. Okay. Yes, moving on. Next one, reaction of metals with acids. So what is the general equation here? Acid is getting treated with metal, we are getting salt. So whenever we are taking acid and we are treating it with metal, we will be getting the formation of salt with the liberation of H2, that is our hydrogen gas. Okay. So what is the equation? We are taking HCl, our general usually taken acid, which is very simple to understand. So we always consider HCl, and you are treating it with our metal, that is a sodium. So what is the reaction happening here? We are getting sodium chloride plus liberation of H2O. What is sodium chloride? It is salt. So our sodium chloride is salt. So we have got the formation of salt with the liberation of H2. So as I always tell in every classes, balancing the chemical equation is very, very important, students. The reaction is not complete until unless you balance the equation. So balancing also plays a very major role in scoring. Okay, to do balance all the reactions, whatever chemical reactions we write down. Okay, next, HNO3, that is our nitric acid, does not give hydrogen gas. It doesn't give hydrogen gas. How? You can see here, we are treating HNO3, that are acid, with sodium. So what is the formation here? We are getting sodium nitrite, okay, sodium nitrite with H2O and also our oxides of nitrogen. So here you can see there is no formation of H2 gas, but what is the formation here? You can see water is formed and our oxides of nitrogen is formed. Okay, this can also be asked as a question. HNO3 does not give hydrogen gas. Explain it with the reaction. This might be a type of the question. So that time you have to write down the equation and write it in the words as well. Okay. Yes, moving on, reaction of metal with other metal salt solution. So metal reacting with other metal salt solution. That continues with iron, you are taking with copper sulfate. Iron is also metal, copper is also metal. So when you are treating it, what happens? We are getting ferrous sulfate with the liberation of copper. Okay, so your metal with other metal salt solution. We are taking iron and copper sulfate. What are we getting? Ferrous sulfate with the liberation of our copper. Again, one more example, we are taking copper and treating it with silver nitrate. So copper, treating it with silver nitrate, we are getting CuNO3 twice. That is a copper nitrate with the liberation of silver. Okay, these are the one of the two examples which I have given for reaction of metal with other metal salt solution. Moving on, yes, the reactivity series. We are learning about this reactivity series since our first chapter, right? I hope by now you are very clear with the reactivity series. What is actually the reactivity series? What is the definition? You can see list of metals arranged in the order of their decreasing activities. Okay, they are how it is actually active or how actually it reacts according to that it is arranged. How? In the decreasing order. So that is called as that is called as reactivity series. So what are the list of elements? Yes, this one is very, very important, students, to remember the series, because based on this only you can get to know lot of equations, how actually the reaction happens, the reaction doesn't happen. All this you will get to know only through this series. Okay, the highest is with our potassium and the lowest is with our gold. So all these elements it is very important to remember all these elements in the reactivity series, because that shows how actually the reaction happens, whether the reaction happens or not. All this you will get to know only through this reactivity series. Okay. Yes. Moving on, the electronic configuration. Actually, electronic configuration, when it comes to your syllabus, it's not in detail. You will be learning it in detail in your 11th and 12th standard. So what are the basic things you are supposed to remember is all I have mentioned here. First thing to remember is metal gives electrons. Metals are those which is giving electrons, okay, and non-metals are those which will take electrons. So this concept you have to be very clear. This one concept you have to remember. Metals will be giving electrons and non-metals will be taking electrons. Followed by, there is something called as shells. What are the shells? Our first orbit is given as, or it is mentioned as K shell. Okay, the first orbit will be mentioned as K shell. Followed by second orbit will be mentioned as L shell. So the K shell will be having how many electrons? 1. And the second shell will be having 2 electrons. Followed by third orbit is given as M shell, and they will be having 3 electrons. The fourth one is N shell, that will be having 4 electrons. So this shells, the letters of the shells is very important to remember, and how many electrons are present. So K will be having 1, L will be having 2, M is 3 and N is 4. K, L, M, N. The shells alphabets are very important to remember. Now, subshell. Next, we learned about shell. Next, we are going, the next division is called as subshell. So what are those named as? See, yes subshell. Okay, yes subshell will be having 2 electrons. Our yes will be having 2 electrons. P will be having 6 electrons. So the number of electrons is 6. D will be having 10 electrons, and followed by F will be having 14 electrons. So what and all you are supposed to remember? K, L, M and N. These are shells, and S, P, D and F. These are subshells. Okay. These are the things which you are supposed to remember. Okay, I will just write it straight so that it will be clear to understand. So what did I tell? K, L, M and N. These are shells. And S, P, D and F. These are subshells. So these alphabets are the one which you are supposed to remember in an electronic configuration. Moving on, the electronic configuration of few elements I have given here. So these are the elements which you are supposed to remember for your syllabus. Okay, you can take some time and see what all are the elements and what are the electronic configuration. I am very sure that you know how this electronic configuration is done, is explained in your actual classes when it was held. So when you can see, hydrogen is having 1s1, helium will be having 1s2, lithium is having 1s2, 2s1, its electronic configuration, beryllium is 1s2, 2s2, boron is 1s2, 2s2, 2p1. As the elements goes, the electronic configuration is becoming larger, right? That difference you can notice here. Now coming to carbon, 1s2, 2s2, 2p2. Nitrogen, 1s2, 2s2, 2p3. Oxygen is 1s2, 2s2, 2p4. Fluorine, is 1:2s2 2p5, neon is 1:2s2 2p6, and the last one is sodium, that is 1:2s2 2p6 3s1. Okay, so how? According to the atomic number, we can also give our electronic configurations. Okay, these are the important electronic configuration which you are remembering in your syllabus. Moving on, yes, reaction of metals and non-metals. So what happens here? Metal and non-metal, when you are treating, what is the reaction happening here? We are getting an ionic compound. What is this ionic compound? What actually happens in ionic compound? What are these ionic compounds? We will learn in this next slide. Okay, so when you're taking metal and non-metal, what is the formation here? We are getting ionic compounds. Here something, there is an explanation of dot structure. Okay, dot structure also can be one of the important questions which is asked in your examination. So to draw the dot structure, valence electron of an element should be known. So the valence electron, whatever, when you're drawing the dot structure, valence electron is very, very important to be known. What is this valence electron? Yes, it's nothing but number of electrons which is present in the last shell. There are, when you take an element, there are number of electrons, there are few electrons which is present in the last shell. I have explained about this valence electron, I think, if I am not wrong, in my periodic classification of elements. How actually this valence electrons, what are these valence electrons, how are they present, all this I have explained in my periodic classification of elements, right? So what is valence electron? Number of electrons present in the last shell. Yes. Moving on to the next concept is formation of NaCl. So how exactly this formation happens? We can see it happens in a 3-step. The first step is by electron transfer method. So what happens basically in our electron transfer? You can see here. Step 1. In step 1, metal loses electrons. Okay. Here metal is losing the electron. We are taking sodium, which undergoes the reaction where one of the electron is lost and we are getting Na+. So when you look into the electronic configuration of sodium, you can see atomic number of sodium is 11. So 8, 9, 10, 11. Atomic number, when you're taking just sodium is 11. So when you undergo the reaction, you can see there is a loss of one of the electron. So our electronic configuration will be only 2 and 8. Right? Moving on, the next step is non-metal. The non-metal, whatever we are considering, that also will be gaining. It is actually the gaining of electrons, students. It's not the loss. Sorry, it is gaining of electrons. So when you see here, chlorine, it is gaining one of the electron and it's becoming Cl minus with the electronic configuration of 2, 8 and 8. So 2, 8 and 7 with the gaining of one electron will become 2, 8 and 8. Okay. It is not losing of electrons, students. It is gaining of electrons. Now, moving on, the last one will be formation of NaCl. The both, one with the loss of electrons and one with the gain of electrons, will combine together and form NaCl. So it's very simple, right? Only 3 steps. The step 1 is, the actual question can be, explain the formation of NaCl is one type, and one more will be how do you get the formation of NaCl by electron transfer method, or explain electron transfer method. That time you can give the example of NaCl. So what is the step 1? The metal loses electrons. So here sodium is going to lose one electron and it is forming Na+. Okay. Then in step 2, our non-metals will be gaining an electron. When you see chlorine will be taking an electron and it will be getting chlorine minus. Okay. Yes, moving on. Next will be the formation of NaCl, that is Na plus and a Cl minus will react together to give NaCl. Next one is the properties of ionic compounds. These are the important properties which you are supposed to remember when it comes to the properties of ionic compounds. What are they? The first one is physical nature. They are solids and also they are hard. They are solid in nature and also they are hard. Followed by the metals, the melting and boiling points. What are the melting and boiling points? high melting point and boiling point because they have strong electrostatic force of attraction. So this is the important point you are supposed to remember, students. That is strong electrostatic force of attraction will be there in our ionic compounds. Then solubility, it is soluble in water but it is insoluble in solvents like kerosene, petrol and etc. So it is soluble in water but it is insoluble in solvents like kerosene and petrol etc. Then conduction of electricity. The molten state or aqueous state can conduct electricity. When it comes to the ionic compounds, the molten and aqueous state that can conduct electricity because of the presence of ions. Okay. Due to the presence of ions, the ionic compounds whatever are there, when they are present in an aqueous or the molten state, they can conduct electricity. Okay. This is also one of the possible type of question which can be asked is explain the conduction of electricity in ionic compounds. So that time you have to write molten state or aqueous state can conduct electricity because they will be having the presence of ions, right? Yes. The last for today's class is reaction of non-metals. So basically the reaction of non-metals is carried on with the same procedure with the general equation and the actual equation. What happens here? So first one is it's reacting with oxygen. When it reacts with oxygen, a non-metal reacting with oxygen, what does it give? It gives a non-metallic oxide. So there when you saw it gave a metallic oxide, right? Here it will be giving a non-metallic oxide. So that is the carbon and oxygen. You are taking carbon and oxygen and it will be giving you the formation of carbon dioxide. So which is a non-metallic oxide. Okay, this is a very simple example. Carbon plus oxygen will be giving you carbon dioxide, which is a non-metallic oxide. Then non-metals will not react with water. Non-metals do not react with water. Non-metals do not react with acids. So non-metals is not reacting with water. Non-metals are not reacting with acids. Non-metals do not show displacement reaction. So basically here the non-metals are reacting only with oxygen. It will not react with water, it will not react with acid, and it is not going to show the displacement reaction. Firstly, you have to know the differences between the minerals and ores. Okay, students, you always have to know there is a difference between minerals and ores. I have given you the definition. You can see elements which occur naturally in the Earth's crust, that is called as minerals. So whatever elements which are found, which will be appearing naturally in our Earth, right, in our Earth's crust, that is called as minerals. And also there is something called as ores. What is it? Extractable metals are called as our ores. So whatever metals we are going to extract, that will be in the form of ores. So how basically this cycle happens, you can see minerals will be converted into metals. Okay, minerals are converted into metals and later the metals are converted into our usable substances. You know, metals we are using in our day-to-day life, right? So how is this actually processed? How actually we are using this? It's from minerals. From minerals we obtain metals, and from metals we are obtaining our reusable substances. And also you can see here, all minerals are not ores. You have to remember this point very well, students. All minerals are not ores, but all ores are minerals. Okay. So what is it? All minerals are not ores, but all ores are minerals. So I hope you are clear with the definition of minerals and ores. Minerals are the substance which will be occurring naturally in our earth crust, but ores are the extractable metals. Now, what is metallurgy? What actually is metallurgy? From all this, how are we obtaining? We took minerals, from that we are getting ores and then we are converting it into some usable substances, right? There is some process which happens. That is something called as metallurgy. So the definition of metallurgy is, it is the branch of science which deals with extraction of metal from ores. So whatever the process which happens is called as, how the process, we are extracting metal from ore, that process is called as metallurgy. So what is the definition for metallurgy? It is a branch of science which deals with the extraction of metals from our ores. That is called as a metallurgy. Now, one more important topic is activity series. What are these activity series which you all would have been remember, right? Activity series, we have given few of the elements here. These are the elements which can be used as metals or which can be extracted and be used as metals. So these are divided into three types. Okay, what are those three types? You can see electrolysis, reduction using carbon, and found in native state. So this is also called as, you can term it as high reactivity, and this is moderate reactivity, and this is low reactivity. So this table you have to remember, students, so that you can classify into three different categories. What is that? Our potassium, sodium, calcium, magnesium and aluminium comes under high reactivity, followed by zinc, iron, Pb and a copper comes under moderate reactivity, and the last one is our silver and gold, which is the low reactivity. So this table you have to remember in order to know which kind of reactions happens, whether it is high reaction, high reactivity, moderate reactivity or low reactivity. Yes. Now, how exactly the process happens? Actually, in your syllabus, you don't have in detail the explanation, the entire explanation of metallurgy process. All you have is just the gist of this flow chart. Basically, what happens, how the process happens. So, in a very just way, I'm going to explain it. You know that we are taking the substance called ore. First, what are we doing it? First, we are processing it with a concentration of ore. We are constant. Then it is further divided into three types, as I told: high reactivity, medium reactivity, and low reactivity. Okay. These are the concentration of ore is divided into three types, that is high, medium, and low. Now, each reactivity elements follows each kind of process. When you can see here, high reactivity follows electrolysis process. Okay, so the high reactivity of the metals, whatever we are taking, that will be following electrolysis process. Followed by, we will be getting directly our pure metal. The next one is medium reactivity. The medium reactivity, we are obtaining two kinds of ores. What are those? Carbonate ores and sulfide ore. So two kinds of ore we are obtaining here, carbonate and sulfide. This undergoes a process called as calcination and roasting. I hope you remember the definition for calcination and roasting. Never mind, I have already mentioned in my next slides what is calcination and what is roasting, if you guys have forgotten it. Okay, so the carbonate ore and the sulfide ore will be following calcination and roasting process. Later, it undergoes oxide of the metal. So here we are getting an oxide of the metal. What happens in the further step? You can see reduction of the metal happens, and lastly we are getting the purified metal. So this is the process for our medium reactivity. And when you come to the low reactivity, we can see it is again appearing in the one form, that is a sulfide ore. The sulfide ore is further undergoing the process called roasting. Here only one process it is undergoing, that is called as roasting. Then followed by metal. We are obtaining a crude metal. The crude metal will not be completely in a pure state. Later, to obtain a pure state, we are undergoing with one more process called as refining. Okay, this is one of the flow chart which you have to remember in order to know what actually happens. How are we getting our pure form or a crude form of metal with our high reactive metals and low reactive metals and the moderate reactive metals. Okay. Moving on, extraction of metal with low reactivity. So extraction of the metal with low reactivity. How basically it happens? Let's see. Yes. First step, what we are taking is concentration of our ore. First happens is the concentration of ore. What are we taking? Which substance we are considering here? Yes, we are considering extraction of mercury from cinnabar. Cinnabar, it's also called as mercury sulfide. Okay, it is also called as mercury sulfide. From this, we are extracting our pure form of mercury. So, what are the steps? The first step is concentration of ore. What happens in the concentration of ore? Here, you're basically removing the impurities present. Okay, the impurities present such as sand and mud particles, what and all are there, those you're removing in a step 1, that is concentration of ore. Those impurities are called as gangue particles. So what are these gangue particles? As I told, impurities such as mud and sand particles present in our ore. So you are taking HGS and treating it with oxygen in the presence of heat. Okay, this is represented as heat. So you are taking HTS, that is acinnabar, and treating it with oxygen in the presence of heat. We are obtaining something called as HGO. What is it? What do you think that HGO is? Yes, you can see our mercury is in the presence of oxygen. Okay, it is some kind of an oxide form, right? I hope you understood what would be the name, right? Yeah. So the liberating liberating product will be our SO2, that is a sulfur oxide. Now, conversion of sulfide ore to oxide form. Okay. Here, there is the conversion happening of a sulfide ore. Whatever we are taking, the sulfide ore is converted into an oxide form. This process is called as roasting. Okay. Now, you remember the definition, right? The conversion of sulfide into the oxide ore, that is called as roasting. Okay. That is called as roasting. Let's move on. You have to remember this definition, student. This, what is roasting, what is calcination, can be asked as a 1 mark question. Or they can also ask, what is roasting? Give example. You can take one of the example from this extraction of mercury and you can mention them. Yes, moving on. The last step is heating of a mercuric oxide. Whatever we got, that mercuric oxide, that is HGO, yes, that is the name of our compound. That we are heating it and we are getting 2Hg plus O2. So we have obtained our Hg in the purest form. Not completely purest form, like almost 90% of it will be pure and 10% will be having some kind of impurities. This can undergo, you want it in 100% in a pure form, the next step will be refining of this. When this is refined, you will be getting a 100% pure form. Okay, I hope you are clear with the extraction of mercury. This comes under which? It comes under low reactivity. Okay. Now, moving on, extraction of metals with moderate reactivity. So you remember, right, what all are the elements present? Here we are basically using Zl. Okay, we are using zinc. We are extracting zinc from a ore called as zinc blend. Or we are also using one more compound here called as zinc carbonate. Let's see what actually happens in this reaction. The step 1 has always concentration of ore. What is concentration of ore? Removal of our impurities, that is gangue particles from the ore. The step 2 is roasting. What is it? Yes, converting sulfide into an oxide form. So what is the reaction happening here? You are taking zinc blend and treating it with oxygen. In the presence of heat, you are getting a zinc oxide with SO2 in the liberating part. Okay. The third step will be calcination. Now we came into the second important definition. What is calcination? Here you can see, I told we are using here zinc blend and zinc carbonate, right? Here we are taking zinc carbonate. In zinc carbonate, you can see what exactly happens. In zinc carbonate, we are treating it in the presence of heat. You will be getting zinc oxide. So what happens here? Carbonate is converted into oxide form, right? This process is called as calcination. So what is the appropriate definition for this? Conversion of carbonate ore into oxide form in the absence of air or oxygen. So in roasting, there was the presence of air or oxygen, right? You have to remember this differences very clearly, students. In roasting, there will be presence of oxygen or air. There what it is happening, sulfide is getting converted into oxide. But here our carbonate ore is converting into oxide. How? It is happening in the presence of heat, but there is no presence of air or oxygen. So this process is called as calcination. Now the last step will be the reduction. Here we are taking carbon as our reducing agent. Okay, so the carbon is taken as reducing agent. So our zinc oxide is treated with carbon and we are getting crude metal, that is zinc, with the liberation of carbon monoxide. Okay, so this is one of the example for our extraction of metal in moderate reactivity. Now let's move on to high reactivity. What actually happens for the metal with high reactivity? So this process is basically called as electrolytic reduction. So this you have to remember, students, the extraction of metals with high reactivity, that is also called as electrolytic reduction. So you can get two types of question here. Either you can get directly extraction of metals with high reactivity, or they can also ask explain electrolytic refining. That way also you can get the question. So this you have to remember it very clearly. Now here what are we extracting? We are extracting our sodium from NaCl. Okay, how actually this process happens? See, we are taking a beaker which is filled with our electrolytes. Okay, which is filled with electrolyte. What is an electrolyte here? What electrolyte we are taking? Yes, we are taking our NaCl. Okay, we are taking NaCl. I'll just change the pen color so that it will be easy for you to understand. Yes. So NaCl is present in our electrolytic solution. So NaCl, students, you have to remember, NaCl is present in molten condition, in molten state. Okay, NaCl will be present in our molten state. Now this is connected to two of our rods. So which is that? One is our cathode rod and one more is an anode rod. So cathode will be having what sign? Yes, our cathode will be having negative sign and our anode will be having positive sign. So the whatever solution, that NaCl solution present, now when the electricity is passed, you are going to get ions. What are those ions? We are going to get here Na plus and Cl minus ions. Okay, when the electricity is passed in the solution, we are getting two kinds of ions here, that is Na plus and Cl minus ions. Now where do you think the Na plus goes and attaches, and where do you think the Cl minus goes and attaches? Yes, our Na plus is going and attaching to our cathode and Cl minus is going and attaching to our anode. So when the electricity is passed, we are getting ions and those ions are getting attached to each of the rods, whatever we are taking. One is cathode and anode. So our Na plus gets attached to our cathode and the Cl minus get attached to our anode. So actually now we got our product. What is that? Na. So how did we get here? One kind of reaction happens. You have to remember these two reactions, very, very important in this answer. These two reactions you have to mention, students, to show what exactly happened in this experiment. So you can see at cathode, Na plus is getting one of the electron. Na plus is getting the electron. So here, whatever it's present, the Na plus got and attached to our cathode, it is getting one of the electron and we are getting our sodium. Okay, this is among these two, this is the important reaction which you have to remember. But you cannot write an incomplete answer, right? You have to mention what happened in our anode also. So in our anode, 2 Cl minus ions, we are getting in 2 Cl plus 2 electrons is liberated. So this is an actual process which happens in our extraction of Na from NaCl, also called as electrolytic refining. So here you have to remember the diagram which can be asked for your exam, and also when you're writing this answer, detailedly you have to explain the experiment, what actually is happening, followed with these two reactions. Okay, So this is one of the example for extraction of metal with high reactivity. Now, let's move on. Next process is called as electrolytic refining. Okay. Next one is nothing but electrolytic refining. What happens here? You can see I have put the definition. What is refining? What is actually refining is purification of crude metals. Now, whatever metals you got, it will be not completely pure. Okay, as I told, 90%, 95% pure it will be. This you have to obtain in complete pure form. There undergoes a process called as refining. So, what is refining? Purification of crude metals after extraction is called as electrolytic refining. So, this is also one of the important definition to remember. So, what is electrolytic refining? Purification of crude metals after extraction is called as electrolytic refining. So, this also happens with one of the experiment. You can notice in the image, we have taken copper sulfate. In our copper sulfate has our electrolyte solution, okay, followed by the cathode and anode connection. The all connection like how it was in the before experiment, it's the same, cathode connection, anode connection, but the solution what we are using here is our copper sulfate solution in a tank. So, when the electricity is passed, what happens here? That is more important. Whatever Cu, that is copper, is present in anode, it comes out to our solution. Okay. After coming out, after that copper comes out to the solution, it moves on to our cathode. So this is exactly what happens in our electrolytic refining. Okay. So once the electricity is passed, whatever the pure copper is present in our anode, that is coming out to the solution. Okay. When it comes out to the solution, later it is going to our cathode side. Okay. The cathode side will be containing pure copper. Okay. So this will be containing pure copper and our anode will be containing impure copper. Okay. So whatever the pure copper is present in our anode side, when the electricity is passed, it comes out. It comes out and it gets attached to our pure copper side. Okay. Then the final part is the whatever the impurities it is present in our anode side, it gets settled down in the tank. You can see in the picture the impurity, the impure particle, whatever is there in our anode side, it gets settled down in our tank. So this is also one of the important questions which can be asked in your board exam, students, for 3 marks. Okay. What is, you can get the question as define electrolytic refining and explain. That would be a very simple process. I mean, simple question. Or else it can be jumbled also and asked how exactly the electrolytic refining happens with the copper sulfate solution. That way also the question can be asked. So this is one of the very, very important question that you have to study in this chapter. Now, moving on, the last part of the chapter is corrosion. What comes to your mind when you hear the word called corrosion? Yes, there is something getting changed, something we are having, that material is getting changed. How? In the presence of oxygen or in the presence of moisture. What is that substance? See, the metal which is exposed, the metal which we are taking, it is getting exposed to air and moisture. Okay, that time there will be a spoilage. There will be some kind of rust type of material present. You can see in the image, right? That brownish kind of rust, that is, we term it as spoilage of metals. Okay. So what is corrosion? Spoilage of metals when exposed to air or moisture is called as corrosion. Okay. This will be the exact definition for corrosion. You can see when you keep certain substances, when you keep the iron key outside for a long time or a silver spoon exposed to the air for the long time, you can see there will be a layer formed on it, right? That is what is called as, that is undergone a process called as corrosion. Okay, that layer whatever is formed, the brown color layer on our iron materials or on our silver materials, there will be a black color layer formed. Those all are the things which has got, you know, the silver and the iron which has undergone the process of corrosion, and that is the result formed on our products. So for this you can give it, I have explained here with 2 examples. Like I told, iron we are taking and it is getting exposed to oxygen and moisture. So what happens here? You can see rust is formed. The rust formula Fe2O3. This X is because any amount of water can be taken. Whatever H2O we are taking here, it can be 1, 2, 3 or so on. So only we represent it as X. So the product whatever we are getting Fe2O3.X H2O, that is nothing but rust. And when you come to silver, silver within the presence of sulfur, it gets a black coat of silver sulfide. Okay, this will be in the present in the color of black color. As I told, when you expose your silver spoon or silver glass to the air or moisture, you can see for a black color layer or a black color coat will be formed. That is what is called as is our Ag2S. Okay, this is the two examples for corrosion. Yes, how can you prevent it? Prevention of corrosion. It happens in 4 ways, 5 ways. What are those? First one is oiling and greasing. Oiling and greasing is a temporary, prevention, like to prevent the substance for small amount of time. So that can be done through oiling and greasing. Second one is painting. If you paint the substances, it will also be protecting. It will also be protecting for some time from getting corroded or it undergoing the corrosion process. The third one is galvanization process. What exactly happens in galvanization process? Here there will be a coating of zinc. Okay, the coating of zinc on the metal. Which metal? Any kind of metal you are taking. Any kind of metal you take and you coat the zinc on it. This will be helping for the protection of the metal for a longer time. So the third process is a galvanization. The next one is anodizing. Anodizing, it's done basically for our aluminium articles. Okay, it is basically done for our aluminium articles. It is coated with Al2O3, aluminium oxide. So the third one will be alloy making. So what exactly is an alloy? That first you have to know. Alloy is homogeneous mixture. Okay, it is an homogeneous mixture that is made by one metal with the combination of another metal or a non-metal. It is a mixture. Why actually this mixture is done? It's just because when this kind of mixture happens, it makes the metal very strong. It makes the metal to exist for a longer time. So this is also one of the method for prevention of corrosion. Okay, you remember it, right? All the points: oiling or greasing, painting, galvanization, anodizing, and alloy making. Right? Okay. Yes, this is end of our chapter for metals and non-metals. Now let us look at the probable type of questions which can be asked in your exams. Yeah, the first question: which of the following pairs will give displacement reactions? Which exactly gives you the displacement reaction? I hope you remember what is displacement reaction, right? Yeah, we have the 4 combinations given. Just look into all the 4 combinations and you have to know, when you look into combination itself, you have to get to know which exactly undergoes displacement reaction. How do you think we can know the displacement reaction? You remember, right? The displacement reaction happens on our reactivity series. Yes, this will be our reactivity series. So you remember, right, what are the reactivity series and what are the elements present? Yes, this is called as the reactivity series. Now you look into the combinations and I hope you would have already found out the answer. Yes, let's look into the answer. Yes, it is AgNO3 solution in copper metal. Why? Why do you think AgNO3 and copper metal? When you look into series, you can see our Ag is less reactive when compared to copper. So when you see all other things, it doesn't go ahead in our reactivity series except for our silver and copper. So your option will be option B, AgNO3 solution in copper metal. So when such kind of question is asked, students, you have to very, very well remember our reactivity series. Through our reactivity series only, you can get to know which undergoes what kind of reaction. Okay? by heart or learn this reactivity series, and then only it will be helpful for such kind of multiple choices questions to you to answer it. Okay. Moving on. Why sodium kept immersed in kerosene? This is one of the reasoning type. Yeah. Why do you think sodium is always kept in the kerosene? Why do you think that process is done? Yes, it is because it is highly reactive. Our sodium is highly reactive. And also when it is exposed to air, it can be explosive and also it might catch fire. So this is the reason our sodium is kept in the kerosene. So when the question is asked why sodium kept immersed in the kerosene, these are three main points you have to remember, students. One is it is highly reactive, and also when it is exposed to air, it is an explosive, and also it might catch fire. These are the 3 points which you're supposed to remember. Moving on, why do ionic compounds have high melting point? Why do ionic compounds have high melting point? I hope you remember the properties of ionic compounds. There is a they have high melting and high boiling point. Why? Its answer is very simple. Because it has strong electrostatic force of attraction. So the ionic compounds are having high and strong electrostatic force of attraction. Due to this, it requires a lot of energy to overcome the force. Therefore, our ionic compounds have high melting point. The key word is for this answer is they have strong electrostatic force of attraction. Okay. Moving on. What is the chemical process required for obtaining metal from its oxide? So you remember, right now only we learnt about it. What is the reaction happening there? Yes. You can see our HgO is undergoing the process with the heat. You will be getting our Hg, that is our mercury and our oxygen in the liberated way. Okay. Our oxygen has a byproduct, sorry. So, what is the chemical process required for metals? For its oxide form, you can take an example from whatever we have learned, that is 2HgO with heat. In the presence of heat, you are getting mercury and oxygen. Moving on, food cans are coated with tin, not with zinc. Food cans are coated with tin and not with zinc. Why? You can see the option. Option A is zinc is costlier than tin, zinc has higher melting point than tin, zinc is more reactive than tin, and zinc is less reactive than tin. So these are the options given. Again, you have to remember our reactivity series. So according to the reactivity series, which is the right answer for us? C. Zinc is more reactive than tin. Okay? Zinc is more reactive than tin. So only our food cans are coated with tin, not zinc. Okay? When you're taking the more reactive substance, it might react with the food particles, whatever is present in the can. So why that might be dangerous to our health. So to avoid that, we are using tin, not zinc, because it is less reactive compared to zinc. Moving on, which of the following oxide is amphoteric? What is this amphoteric? What do you think amphoteric is? You remember, right? Yes, our amphoteric is nothing but it will be the combination which will be reacting with both acids and bases. Okay, so what do you think among the option? What do you think is the right option here? I hope you already got what is the right option. Yes, it is our aluminium oxide. So what is amphoteric oxide will be our next question. Yes. Which metals do not corrode easily? Which metals do not corrode easily? That is are silver and gold. Silver and gold will not corrode easily because when you see in our reactivity series, it is a low reactive. It is very, very low reactive present in our reactivity series. So which metals do not corrode easily? You can give an example of silver and gold. Yes, here is the question which I told. What are amphoteric oxide? This is one of the very, very important questions, students. You have to remember this and you have to learn this. What are amphoteric oxides and give example is a very, very important question. Yes, oxides that behave as both acidic and bases. This is called as amphoteric oxides. So oxides that will be behaving both as acid as well as bases. This is called as amphoteric oxides. So what are the examples here? Zinc oxide and aluminium oxide. So aluminium oxide is mentioned here in our example also. In our last question also it was mentioned, right? Which of the following? Yes, the aluminium oxide is our amphoteric oxide. Moving on, give reason. Platinum and gold are used to make jewelry. Platinum and gold are used to make jewelry. Why? Why do you think it is used to make jewelry? Yes, they are lustrous. What is lustrous? Lustrous is nothing but it is shiny. It is shiny substance, right? The gold and silver or the gold and platinum, whichever you take. The silver also, it is also lustrous. It is shiny. And also, they are very less reactive. As I told, it is very less reactive when you see in a reactivity series. So therefore, this is used in making jewelry. So gold, and what is the key word for this? They are lustrous, that is shiny, and they are less reactive. Therefore, they are used in preparation of jewelries. Next, this is also one of the important questions, students, which can be asked in your exams. Okay, give the differences between metals and non-metals. It can be asked for 2 marks, it can be asked for 3 marks, it can be asked for 4 marks also. Okay, when 2 marks, you know how many points you're supposed to write, and 3 marks, how many. As the marks increases, the points also should increase. So the main difference is what I have mentioned here about metals and non-metals. One by one, we go through. So here metals are hard, and when it comes to non-metals, it is soft. Metals here exist in solid form. Here it exists either in solid or in gaseous state. Next, they are malleable. They are malleable, and these are non-malleable. These are ductiles and these are non-ductiles. Good conductors of electricity and bad conductors of electricity are non-metals. They are lustrous and sonorous. These are not lustrous or not sonorous. They have high melting point and these have low melting point. Okay, these points I have explained in my last session, like what exactly is called as malleable, what is ductile. All this I have explained in my last session, right? So only I have just read whatever is there on the screen. So what are the differences between metals and non-metals? I hope you understood. So anything that's asked for 2 marks, 3 marks, 4 marks, you should be able to write all the important points for the differences of our metals and non-metals. Yes, with this, we have come to the end of the chapter metals and non-metals with our one-shot revision. We dealt here all the information, all important concepts of our metals and non-metals followed with probable type of questions for our exams. I hope you understood what all are the important concepts you're supposed to remember in this chapter, and also what type of questions might appear in your exams. So in next session, we will deal with our another new chapter. Which is it? Yes, our carbon and its compounds. There we will learn all the important concepts or what all important points you're supposed to remember in the examination point of view, and also the probable type of questions. So until then, this is Vista's Learning, quality education for all. If you have liked my class,